Okay, in this video I want to go over how to value stocks and bonds. And one of the most important elements of this valuation is going to be present value. Present value is essentially taking some future value and converting it into a form that has meaning today. And the concept of present value can be understood by considering the way we value money across time. If I were to offer you $100 right now or $100 a year from now, you would take the $100 now. That means you have a preference for the same amount of money sooner rather than later. And that should make sense because if you have $100 now, you could invest that and turn it into more than $100 a year from now. So clearly $100 now is valued more than $100 a year from now. With that in mind, we can take any future values and convert them into present values with this formula here. So let me just do a hypothetical example here. Let's say that we have $100 to be received 1 year from now. And let's assume that in the economy, the interest rate, this is actually called the discount rate, which is the return that you could get on an investment. Let's say that's 10%. So we would put 100 over 1 plus 10%, so 1.10. And we would take that to n, which is the year in which that future payment is going to be made. So because this $100 is going to be received 1 year from now, and the return that you could earn on that $100 is 10%, then this is the formula that we would use to determine how much that is worth today. If you do the math, you would have 100 divided by 1.1, and I can use my calculator for this. Which is $90.91. So we would say this is equal to $90.91. In other words, $100 received 1 year from now, assuming interest rates on investments are 10%, would be the same as having $90.91 today. And you can understand this by changing this formula and solving for the future value. So this might make a little more sense, but you could say that future value is actually equal to present value multiplied by 1 plus the interest rate to the nth power. These are the same formula, but you're just solving for future value. Now let's use this. So if we had $90.91 today, that would be the present value, and we earned a 10% return, this would be 1.10 to the first power, then this would equal $100. So think about this. $100 a year from now, assuming a discount rate of 10%, is equivalent to $90.91. But that's the same as saying that $90.91 today is equal to $100 a year from now, assuming the return discount rate is 10%. So these two formulas are a good way to understand the time value of money. And these are, in many ways, fundamental in the discipline of finance, because when we're dealing with stocks and bonds, what we're dealing with is future values. I mean, think about it. When you buy a stock, you're going to get that dividend in the future. When you buy a bond, you're going to get that coupon in the future. So stocks and bonds are providing future value. But how do you determine the present value of those future returns? Well, you have to use this formula. In fact, let's continue on and look at an example. Let's suppose that you win a contest and you're paid $50,000 immediately and $50,000 each year for 4 subsequent years. Assuming a 10% interest rate, the present value is calculated as, well, you're getting $50,000 right away. So there's no need to discount that, right? Because $50,000 received today is the same as $50,000 received today. But look what happens the first year. Remember, you're going to get $50,000 each year for 4 years. So this first year, 1 year from now, you're going to get $50,000. Assuming that the discount rate is 10%, you take $50,000, you divide it by 1 plus 0.1, which is 1.1, and that gives you $45,454. Why? Well, because if you had $45,454 today and you invested that at 10%, you would have $50,000 a year from now. Therefore, $50,000 received a year from now, assuming a 10% interest rate, is worth $45,454 today. Let's keep going. If you receive another $50,000 payment 2 years from now, you take the $50,000, discount it by 1.1 to the second, you get $41,322. Why? Why is $50,000 received 2 years from now the same as $41,322 today? Because if you had $41,322 today and you invested that at 10% for 2 years, you would have $50,000 2 years from now. Let's keep going. If you receive $50,000 3 years from now, take $50,000 divided by 1 plus 0.1 to the third. That gives you $37,565. Why? Because if you had $37,565 today and you invested that at 10% for 3 years, you would have $50,000 3 years from now. And the process continues. If you have a contest in this case that provides you the future income streams of $50,000 right away, which is a present amount, but then $50,000 1 year, 2 years, 3 years, and 4 years from now, then in order to determine the value of that contest in today's terms, you'd simply need to add up the present value of all of these payments. And if you do that, you get $208,493. What does this mean? It means that if you had $208,493,000 and you could get a 10% return on that, you could create this same income stream of $50,000 right away, $50,000 a year from now, 2 years from now, 3 years from now, and 4 years from now. Therefore, this stream of payments, essentially 5 $50,000 payments, is worth $208,493,000. Some of you may be thinking, well, 50,000 times 5 payments is $250,000. And you would be right. Yes, you are going to receive $250,000 in value. But the present value of that is only $208,493. It's less because money received in the future is worth less today. This $50,000 received a year from now is worth $45,454 today because you could earn a return over the next year on this and turn it into $50,000. So the present value of future payments will always be less than the sum of the actual dollar values that you get. That's why we call the interest rate here the discount rate, because what are we doing? We're taking future values and we're discounting them. We're creating a smaller number to make it a present value today. All right. Now, you may have noticed something. When we look at this contest here, it's really just a stream of future payments. That's similar to a bond or a stock. So what we just did, even though it's a contest, is analogous to what we'll do with bonds and stocks. Okay, before we get to the details of each of those, understand that the discount rate is always inverse to the price of the asset. So for example, if this discount rate, this 10% that we're using in our example, if this were to go up, then that would raise the denominator. That means that it would lower the present value of that future payment. Take a look. Let's go back up to here, and instead of 100 divided by 1.1, I'll do it over here. Let's say it's 100 divided by 1.2. Well, clearly those would be higher interest rates. So if I use my calculator here, I can take 100 divided by 1.2, and I get 83.33. What happened? The present value of this $100 to be received a year from now went from $90.91 to $83.83. Clearly, this $100 received a year from now is worth less today. Of course it is. Because if interest rates are 20% in the economy, you only need $83.33 today to turn that into, at 20% interest, $100 a year from now. Whereas if interest rates were 10%, then you needed $90.91 today in order to turn that into $100 a year from now. So as interest rates go up in the economy, the present value goes down, which actually lowers the value of an asset. And you'll see this in stock markets, you'll see it in bond markets. When interest rates climb, the values, all else equal, drop. The opposite, of course, is true as well. If we go from a higher interest rate to a lower interest rate, then the present value goes up. Okay, now let's take a look at the specific calculations for bonds and stocks. The process mathematically is the same. We're taking a future value and we're turning it into a present value. What will differ is a few details, like the way we identify what a future payment is called. For example, when you're dealing with bonds, the bond price, which is the present value, is going to be equal to the coupon divided by the discount rate. Notice this is the same formula as we have here. It's identical. It's just instead of future value, we put coupon because the future value of the bond is the coupon payment. And instead of present value, we put the bond price because that's what someone would be willing to pay. You're only going to be willing to pay the present value of the bond, the future flow of income. So you do the same thing. You then find the coupon for the first year, discount that, find the coupon for the second year, discount that, and keep going. Now, one thing to keep in mind is when you get to the final year of a bond, okay, notice here it just goes on. I mean, this could be a 3-year bond, it could be a 10-year bond, a 30-year bond. It goes from 1 to 2, and then we jump to N because we don't have a specific period for the formula. But let's say that this is the 10th year, and the 10th year is the maturity of the bond. So in that 10th year, you're actually going to get 2 payments. You're going to get the coupon for that year, just like every year preceding, but you're also going to get the face value. Remember, bonds are loans, and the company that issued the bond in the date of maturity, that final year, 10 here, has to pay back the amount that they borrowed. So if it's $1,000, then there'd be $1,000 that the company would pay back. If it's $10,000, this would be $10,000. But in the final year, you get 2 payments. So we got to consider both. Let's do an example. Let's say that we have a bond with a face value of 1,000, and it pays a coupon of 20 annually, and it matures in 2 years. And let's assume there's a 6% discount rate, which means interest rates are 6% in the economy. Simply plug in the info. We're going to get $20 the first year, discount that. We're going to get $20 the second year, discount that. And then, since this is a 2-year bond, we're also going to get that face value in the second year of 1,000, so you discount that. Then you add these up and you get $926.66, which means someone would be willing to pay up to $926.66 to get $20 a year from now, $20 2 years from now, and $1,000 2 years from now, assuming interest rates are 6% in the economy. Why? Because if you had this amount and you invested it at 6%, you could create this exact flow yourself.